That's a really good question. And it has two distinct components. One is trust, and the other one is basically sustainability of AI in operational environments. So I'll tackle the first one first. On trust, what one thing that makes a huge difference is you just don't build AI for accuracy. What is the accuracy of this model? 98%, 99, that's really not the question. You build it for reliability. AI needs to be able, especially in industrial environments, to reliably handle the harsh environment that our operators live in, our users live in. Sensors go bad. There's not a consistent network connectivity. So AI needs to be architected properly to handle those situations and still deliver value, deliver the right results when the user needs it in the field, right where a maintenance operator, a repair technician is trying to change a gasket for a compressor, and all of a sudden he or she needs to know what are the steps. AI needs to be there. So that is the trust part. The other element of trust is you want to make sure that AI consistently delivers good answers. That requires also just not focusing on the model alone. The architecture requires a little deeper integration of data components. The big one is knowledge graph that virtually eliminates hallucination, and that builds trust. Building knowledge graph is expensive, is lengthy. Pre-Gen AI and agentic AI era, we used to spend months and years to build the knowledge graph, and that was when we would start first building our first applications. Now we don't have to do that. Something that took 12 months in pre-AI era, now a product like ours, IntuigenceAI product, delivers it at 12 hours, 12 months to 12 hours. And that change this and disruption in the required investment to make AI trustable by virtually eliminating hallucination is a key factor. On the sustainability part, there are multiple aspects that an AI implementation can take into consideration to make AI sustainable. One is we truly need to look at compute and power that is consumed by compute as a very valid engineering constraint. We should take it into account when we build and architect an AI-based system for industrial operations. I mentioned the knowledge graph. Knowledge graphs are very efficient in retrieval. When you ask a question from a model, a large language model, for example, sometimes trillions of parameters need to be evaluated for the model to land on an answer. Every single of those evaluations take compute. Compute takes power. With a knowledge graph, the software can go through the knowledge graph with 3-4 hops of traversing the knowledge graph, get to the answer. A lot more, orders of magnitude, computationally more efficient. So that's another one. The second one is data quality. We have dealt with data quality for a long time. Bad data leads to bad AI. Bad quality data leads to bad quality AI. If we basically put some effort early on in the value chain of data and address data quality downstream before it gets to the model, we save a lot on inferencing and training. You train the model with bad data, you get bad training and you get bad responses. And that also creates a cycle of retraining and reinferencing and re-asking the question and the query, all consuming power. So data quality is a major one. The other one is governance, security, various availability, various aspects of governance. When you deploy AI to an industrial environment, setting these engineering and architectural dimensions correctly allows the user to interact with the AI and get the answers much faster and much quicker within the constraints that the organization, especially the IT organization, sets. So these are a few aspects of building AI for industrial environments that make AI trustable and also sustainable. So SOC 2 is a major step in any enterprise software deployment. SOC 2 is a badge of, we have gone through several, almost 200, various different controls and checks around data security, around privacy, around PII control, personally identifiable information, around availability, and we certify this piece of software that this software complies with all of those checkpoints. And then there is a badge, there is a certification, independent audit, not the company saying, hey, we're good, we're secure. There is an independent auditor that comes to the company. They check all of those various checkpoints. And that's basically to reduce a few things. The big one is buyer's anxiety. When I see as a buyer this piece of software is SOC 2 certified, I pretty much trust that someone independent of the company has gone through their software, their engineering practices, their architecture, even sometimes pen testing, penetration testing, to make sure that the software is robust enough from enterprise security and privacy perspective. So that's buyer anxiety. The second one is it significantly shortens the purchase process. IT organization on the buyer side, they know SOC 2. They understand it. They have worked with it before. So that badge of basically confidence and vote of confidence allows them to push through the purchase process a lot faster. And at the end of the day, when you buy a car, you want to make sure it's crash tested by an independent party. You want to make sure that it doesn't, like if you drive through the rain doesn't leak in. Those tests are important. In the software world, SOC 2 is one of those confidence building measures that any serious software company has to do. Not everyone does it, but the serious ones do, and we have done it, and we're proud to be SOC 2 certified. So as a company, what we have built is we have built a platform that can absorb digitized knowledge across the organization, especially in industrial domain and data sources. Those are engineering diagrams, PNIDs, PFDs. Those are various types of industrial IoT data, time series particularly out of Pi, Aviva Pi or OSI Pi. Documents, various types of complex documents, and typical systems of record, which is primarily SAP. We capture those pieces of data, plus domain expertise in specific engineering domains that are important for industrial operation. In our target market is chemical and process engineering, mechanical and rotating engineering, and electrical and instrumentation engineering. These three engineers, we have built them. We have trained them at PhD level in each of these domains. They can go onboard a plant's data, those four data types that I mentioned, in a matter of hours, as I mentioned. And all of a sudden, they know the plant better than an engineer that has worked on that plant for 25 years. Truly superhuman. And then they provide this knowledge, they use this knowledge as basically a colleague to human engineers, or they do tasks and workflows for human engineers. What's next? Obviously, we're currently focused on operations. These three disciplines are very clearly focused on operations. The next one is pre-operations, which is EPC. So we are training EPC engineers for various stages of EPC and building plants before they get commissioned to operations. But at the end of the day, our platform is really very horizontal in terms of absorbing digitized knowledge from different sources of knowledge in any domain and absorbing human knowledge. We have a very exciting feature in our platform that AI agents, our AI agents, interview human experts. There are lots of tribal knowledge that is not captured in documents. They're not digitized. But Joe knows it. Linda knows it. We interview Joe and Linda on those topics. We absorb those transcriptions. We turn them into structured data, and we feed them as part of that knowledge graph that our synthetic engineers operate on. And as a result, sky's the limit. Our goal is to put 1 billion synthetic engineers on the planet. Ambitious goals, but doable, very doable. When you put it in the context of our world has been built today, we have 30 million engineers. Everything you see, cars, computers, water tap, roads, construction, buildings, airplanes, 30 million engineer. What the world would look like if we had 1 billion engineer in the world. That's the world that we're building. These cultural barriers, I would put it in a little broader term. People-related barriers are, they manifest themselves in a few different dimensions. The first one is there is a true fear of, as a human expert, what is my role in this wild future that AI is taking over some of these tasks? And that's a real fear. But when you look at it from a lens and a perspective that some of the works that we do as humans, they really don't deserve human time. They're mundane, they're drudgery, they're repetitive, they're boring. AI can handle many of those. So we should kind of mentally go beyond that thinking that my time, my life is so much more valuable to do this. One of our customers, for example, their team receives thousands of documents, reports from their vendors. They build mega projects, mega plans. And these reports, these weekly reports, someone needs to go through them and figure out whether we're missing a schedule, we're going to go over budget, things are working, something is not available. And senior human engineers read these reports. That's a waste of time of a human expert's creativity. AI can do that a lot faster, a lot cheaper, a lot more consistently. So let's keep that in mind, that some of the work pieces that we do, they don't really deserve human time. The second one is AI accurate? Is AI trustable? Can I trust AI? And that's a very valid question. That's a very valid perspective. The way I see our industry is evolving is we need to find pieces of work, tasks that are fit for AI. AI cannot do everything. There are kind of two sides of the spectrum in how people look at AI. On one side, some people say, do it everything. I want AI to just build a flying car for me. The other side of the spectrum says, no, I don't trust AI. I need to approve everything, even AI, when AI does it. Either side of this spectrum, it's not a winning strategy for deploying AI. The right answer is, like always, in the middle, and that is find the right workflow, the right task that has low to moderate complexity, low to moderate consequence, if AI gets it wrong, and make sure that we give AI the task that AI is capable of doing it properly. There are tasks that should never be given to AI to do. If a decision, a task can kill people, a human has to be always accountable and make that call. If the workflow or task can lead to a major destruction of equipments and assets. That should not be given to AI. If there is going to be irreversible consequences for safety or compliance issues, that should not be given to AI. But if we give the right task to AI, and that's how we see it as our customers are deploying our synthetic engineers, they are ahead of the game. They're winning. They are getting efficiencies. Their workers and experts and engineers are elevating their skills. They are running operations better than their competition. But the key here is pick the right AI for the task and pick the right task for the AI.